That is right. All right, as you see here, we're approximately right here right now. We're gonna do multiplication of whole numbers. If we have time, we'll do division also. But again, I don't know if we're gonna have that much time. But if we start it, then you know the concepts of division as well. So I will try to finish as far as we can. When we come back from spring break, we're gonna discuss the concept of divisibility. How do you know if a number is divisible by, say, 5? What are the characteristics of a number that's divisible by 5? Right. They end with a 0 or a 5. If they end with a 0 or 5, then you know they're divisible by 5. How about if it's divisible by 3? Or 2? Let's say this is going to be easier. How do you know if it's divisible by 2? What's that? It ends with a 0 or an even number. There's a whole bunch of these rules, shortcuts. I'm going to give you a sheet when we come back. But again, division is the topic of algebra that most students don't like because they were never really introduced it correctly. It was just forced on them at the last minute. So we're going to see how far we can get. I mean, today's not going to be any different because if we don't have time, I'm just going to cram it down your throats. So, but I'll do as best I can. So first off, we're going to talk about multiplication, the easy part. What is multiplication?
Addition compacted into
Not compacted. Just keep it simple. What is multiplication? You're right. It has to do with addition, but what about addition? It's not compacted. Strong word. It's simply repeated addition. That's all it is. For example, if we had 3 plus 3 plus 3 plus 3, they're all the same number and they occur four times. You see the connection now. Since it repeats itself, bless you, since it repeats itself four times, the multiplication concept is 3, what's the symbols mean? Times 4. That's the reason they got that word for it. It happens, it repeats itself 3 times or 5 times. That's why it's 3 times 5. This equals 12. Here's a very important note. Multiplication is the only binary operator that doesn't have to be there to exist. Multiplication is the only binary operator. Okay, let's go back. We have to know the words. What does binary operator mean? No. You're just trying to separate the word in pieces. No. What does binary operator mean? Yes. Binary operators are these. Actually, we'll even go one step further, go equals also. So whenever we say binary operators, we're simply talking about the algebraic symbols. The reason being because they don't mean anything unless there are two numbers, one number in front, one number behind it. That means absolutely nothing. Now it means something. Now we have an answer. What is this called? Division is a symbol. It's not an equation. Why can't it not be an equation? Does that what? Nope. Let's look at that word. Is there anything in that word that means something mathematical? That could mean something mathematical. Ah, equal. Is there an equal sign there? So it's not an equation. Now it's an equation. This is a statement. We talked about that in chapter 1. I know it's been a couple of minutes, a couple of text messages ago. Now, the difference between sets and numbers. Remember, when did we talk about sets? What are sets? Was anybody here when we talked about it? We spent the first 3 weeks of the semester talking about them.
It was the lock.
What's that?
It was the lock.
That's a list of objects, a set. Remember, they were defined by capital letters and they consist of elements. That is a set. Anything inside this is a set. Numbers are just pretty much the elements. Why is this important? Because when we talk about sets, we can have multiplication of sets, but it's not the same as multiplication of numbers. If we had two sets A and B, this is called the cross product. It doesn't mean multiplication. It means cross product. It means all the elements of A are multiplied to all the elements of B. As opposed to numbers. Now it means times. 3 times 2 is 6. This is referred to as a Cartesian product. or the full name of it is Cartesian cross product. Let's see how these connect to each other. Since we've talked about sets before. We have two sets. The multiplication of these well, what would that be? What would that value be? What would that value be? What does this n mean? What is this name of this n? What is it looking for? Remember we looked up in chapter 1. It's called a what? Right. It means the number of elements of A, but what is it called? The cardinality, the cardinal number. The cardinal number is the number that represents the number of elements in a set. So here's a definition of multiplication since we're dealing with whole numbers. Using the Cartesian product model. Because we started off the semester talking about sets. Now we're jumping into numbers. There has to be a connection between the two. First, A and B are finite sets. What does that mean? What does finite set mean? Right. Each set, A and B, has a solid number of numbers or elements inside it. If it didn't change, it'd be called a constant. But no, it just simply means that set A and set B have a physical number of numbers you can get to, you can count to it. Then, if the cardinality of A, let's call it little a, and the cardinality of B equals little b, then the multiplication of A times B is equal to the cardinal number of the cross product of sets A and B. Okay, right now it means nothing to you. But let's look at an example here. Let's say set A is A and B, and set B is made up of X and Y. So first off, we look at the first condition. The cardinality of A is what? Let's make it ABC. Makes it a little bit more interesting for us. So set A is ABC, set B is XY. So what is this going to equal? 3. Because there's 3 elements inside there. And we call that the little a. The cardinality of B is 2, and we call that the little b. So far, so good? So now we can do this side here. Little a, so A times B is 3 times 2 equals 6. That's the easy part. How does that relate to sets? What does this mean? We first have to look at this. We have to first look at A cross B. That's, you don't read it A times B, you read it A cross B, because it's a Cartesian cross product. What this consists of, each element of the first set is multiplied to each element of the second set. So what does A multiply to? A goes with X. That's the first one. Then A goes with Y. Now B. B goes with X. Then B goes with Y. Then C goes with X, and C goes with Y. So far, so good? So that's A cross B. So what would the cardinality of A cross B be equal to? 1, 2, 3, 4, 5, 6. Right. This is how multiplication was developed. Because remember, everything started off with logic. Now, how does this relate to what we do with kids in school? This is how we teach multiplication. If we have 3 of these objects and we have 2 of these objects and we multiply them together, how many do we have? Well, adding is easy. 3 plus 2 is we have 5 objects. But how do we do this with multiplication? This is how we do it. We said that each element you have in the one hand multiplies each element in the second hand. You could do that how many different ways? You can do that 6 ways. That's what multiplication really means. Pretty good. So far, so good. Yeah, so it means more than just repeated addition. That's just a watered down, easy thing we tell students. But this is what addition means, multiplication means. Let's look at the properties of multiplication. Have we talked about properties before? Yes, very good. We talked about them for addition. What was the first property we talked about? Yes, the commutative property of, now we had a colon. When we first talked about it, we had addition, and then we had multiplication. Remember how we defined it? What does commutative mean? What does to commute mean? So the addition one was x plus y is the same thing as y plus x. Multiplication is x times y is equal to y times x. Oh, I never finished that note I made earlier. What are the symbols for multiplication? Those are the four symbols. That's a period at the end of it. Because we can have A times B. 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 Again, multiplication is only one that has this many different things you can do. Competing in their class. So these are the symbols we use in multiplication. Remember, now this, again, it looks like the cross product, but we can transform it. These are numbers, A and B are numbers. We could convert it to, once we deal with sets, now we deal with the cross product. Because the cross product simply tells us all the combinations we can make of the two numbers, of two sets. The second property we talked about. The associative property of, when we say associate, what do? We form groups. This is when we do grouping. X plus Y plus Z equals X plus Y plus Z. It's just now we have to introduce the concept of the parenthesis. The students can't do it. No, and we do the same thing with multiplication. We introduce the concept of the parenthesis. Because remember, order of operations tells us to do what's inside the parentheses first. Then we have the distributive property, where we combine the addition and multiplication. So again, this is multiplication because it doesn't have to be there if there's nothing between the two sets. There's always something in front of a parenthesis. Actually, to be honest with you, there's always something in front of everything. The number X, the letter X, it has a 1 in front of it. So it's 1 times X. It has a 1 below it. So there's always a one everywhere. So this is a times x. We have ax plus a y. Then we had the nullity property. We had a couple other ones, but x plus what gives me 0? Negative x. It's just the opposite. Whenever you're adding, it's always the opposite. In multiplication, x times what gives me 0? 0. Anything times 0 is 0. Anything times 1 is itself. Oh, do one more. The identity property. The identity property. X plus what gives me x? Nope. Zero. Anything plus 0 is itself. X times what gives me x? So anything times 0 is what? 0. Anything plus 0 is itself. Anything times 1. Anything divided by 0. Very good. Why not?
Provide something that isn't there.
Actually, it's a little bit. Here we have 2 possibilities. I know we haven't gotten division yet, but how many times does 0 go into any number?
Not at all.
Infinite numbers. Because 0, for example, if I promise to give you nothing, how many ways can I do that? Infinite ways. So that's why they call it undefined. Because infinity is not really a defined number. It's a symbol. How many times does a number go into 0? 0 times. For example, 0 divided by 3 is 0. Because 3 does not fit into 0. Does 0 fit into 3? Yes. Infinite number of ways. So we know that repeated addition is multiplication. What about repeated multiplication? What's that called?
Exponent.
Repeated addition equals multiplication. Repeated multiplication equals exponents. There's an example of an exponent. This number up here is called the exponent. What is this number down here called? It's a 4-letter word. You have 4 of them in a baseball diamond. Yeah, first base, second base, third base, and home base, home plate. The exponent tells you the number of times you multiply the base to itself. So this is the base, that's the exponent. So I say, I take the base and multiply it to itself 5 times. This is the reason why we use exponents, because instead of writing out all these numbers, it's much easier to make it just a 2-digit number. So what does that equal? Well, let's see. If you're given big numbers to multiply, one of the strategies is combine the terms you want to, because they're all multiplication. So you can move them around how you want to. You can combine them how you want to. What is 3 times 3? What is 3 times 3? Okay, what is 9 times 9? 3 times 1 is 3 times 8, 24. And there you have it. Or if you want to, you could have done it 81 times 3. Same thing. 3 times 1 is 3. 3 times 8 is 24. We're building up on getting into larger numbers. Oh, I forgot to tell you one thing before we get to properties of exponents. If we combine the concepts of Cartesian cross products with the multiplication principle, here we have 2 equations, 2 sets of numbers. We can't combine X and Y. So we have 2 sets of numbers. So here's how, remember that earlier thing we had was A dot B equals N A cross B. So little a, little b tell us what? How many numbers were each in each set? How many numbers are in this set? How many numbers are in this set? 2 more. So 2 times 2 is 4. So when we finish multiplying this, we're going to have 4 different numbers. Those guys. So let's see. X times A is XA. Positive times positive is positive. X times B is XB. That's it for that one. Positive times positive is positive. Y times A is YA. Positive times positive is positive. Y times B is YB. And there you have it. Those are your four numbers. Have you seen this before? They gave it another name in high school that students just memorize. What is this method called? FOIL method. First, you took the first numbers, multiplied them together. Outer. So you took the outer numbers, XB. Then you took the inner numbers. And then you took the last numbers. That's the acronym for FOIL. First, outer, inner, last. But that's a one-use tool. Does the FOIL technique work here? No. Because FOIL only has four numbers, four outcomes. So we have 2 times 2. That's how it gets 4. This is a 2 times 3. Which means we're going to end up with 6 answers. Okay, so we can't use FOIL. What we can use is what this rule is called. It's called distributivity. Remember, what is distributivity? Whatever's in front of a parenthesis multiplies to each term inside there. Did I ever tell you what A was? I never said it was a number. It could be a number. It could be a sign. It could be negative sign. It could be another equation. It could be another equation. So we take everything from this first parenthesis and multiply it to everything in the second parenthesis. That's distributivity. X times A is XA. Positive, they're both positive. X times B is XB. They're both positive. X times C is XC. Well, that gets rid of the X because it's finished with all 3 of them. Now I got to do the Y's. They're both positives. YA, YB, and then YC. And there we have our 6 numbers. That's how it relates to what we talked about earlier, the definition of the cross product of sets versus the number of multiplications. I know. How many of y'all ever seen this before in discussing mathematics or multiplication? You've seen it before in this way, using set notations? Where'd you learn that?
Pre-calculus.
Oh, okay, yeah. So, but not in high school or anything like that.
That was in high school.
Okay, that's amazing because it's not many students do that. So you got lucky there. But typically students don't see that because teachers don't know that. So there you have the rule. Now let's look at the properties of exponents. The first property. If you have the same bases, well, in all these, you have to have the same bases. You can't combine them if they're different bases. If you have the same bases, then you can add the exponents. Why? Let's see. 3 to the power 2 times 3 to the power 3. According to this rule, answer is going to be what? Bless you. So since they have the same bases, we can add the exponents. That still doesn't answer why. Here's the why. What does 3 to the power 2 mean? 3 times 3. Times 3 to the power 3 means 3 times 3 times 3. They're all the same. How many of them do we have? So that's it's just a shortcut of doing that rule. If you're dividing two numbers that are exponentials and have the same base, why? Then we subtract. Again, these are easy answers, but you know it if you could tell me why. That was just a safe guess because that one's a plus. This one's got to be minus. It doesn't tell me why. Let's see. Let's look at this. 3 to the 4th divided by 3 to the 2nd.
That's allowed.
So what the shortcut tells us, since they're the same bases, we take the top minus the bottom. 4 minus 2 is 2. Yes, and that's exactly why, is because on top we have 4 3s. On the bottom, we have 2 3s. Since they're all multiplied, we can cancel. And what we're left with is 3 squared. The third property. If you have a power to a power, you multiply the exponents. So if we had 3 squared cubed, this is 3. Since these are power to a power, you multiply, which is 3 to the 6th. But here's the why. The outer exponent, what is it? What is the reason? What is the definition of an exponent? What does it do?
Multiplies the number itself.
What number? The base. So the base of this number is this. So we get 3 squared times 3 squared times 3 squared. It happens 3 times. Well, what is 3 squared? It's 3 times 3. This is multiplied. 3 times 3. It's multiplied. They're all 3s, and we have 6 of them. So that's a shortcut for doing that. What if m, the exponent on the bottom, is bigger than the one on top? If we do the subtraction and the one bigger is on the bottom, what happens? It becomes a negative. Let's call that negative p. Because n minus m, since m is bigger, it's going to be negative. Let's call it negative p. You cannot have the negative in front of the exponent does not make the answer negative. Because remember, they're all multiplied. So what it tells us, if you have a negative and the number's on top, move it to the bottom and drop the negative. So if we had x to the power negative 3 over 2, what would that be? Since this is a negative exponent, it has to go on the bottom. So we have a 1 on top. There's that 2 on the bottom, and we bring that one. And in other words, you can never have your answer as a negative exponent in mathematics. What if we had this? Do we move the 2? No, it is what it is. It's on top. This one has a negative exponent, so it has to come on top and drop the negative. Knowing what we know so far, we can do this in 2 ways. We can do this 2 different ways. Just using the rules that we know so far.
The x and exponent up.
Yeah, since this is negative, I move the whole thing up to the top. Now what do I do? Since they're the same bases, I'm multiplying them. I add the exponents. X to the 8th. That's my answer. What's another way of doing it? What's the definition? The rule of division of exponents. Take the top exponent minus whatever the bottom one is. That's rule number 2 we talked about. Negative and negative becomes a positive. So we have 3 plus 5, which is x to the power 8. Same answer. As long as you follow the rules, you'll get the same answer. But I still never explained why this is so. Because if we do the division, the subtraction one, 3 minus 5 is negative 2. But let's see, what do we have on top? We have 3 x's. We have 5 x's on the bottom. Same thing, since we're dividing same terms, we can cancel. Once we cancel, what do we have left? two x's on the bottom. So what's on top? A 1. This is very important. If you have a fraction and everything disappears on top, the most common mistake students do, they'll put, there's two x's, they'll put x squared. There's still that dividing line there. So then remember, everything always has a 1. X divided by x is 1. X divided by x is 1. X divided by x is 1. What is 1 times 1 times 1? 1. If you have a fraction, there's more numbers on the bottom, you're going to end up with a fraction. And knowing what we know so far, since this is on the bottom, we can move it up on top and we get this, which is what we would have gotten if we did the 3 minus 5. From rule 2. So far, so good. Again, these are rules. Again, these are rules that you have to remember because you have to teach it to the kids. Not remember, you have to know it. There's more. Don't just memorize things. Never memorize things. You have to learn them. If you're going to be a good teacher, you have to know this stuff inside and out. The last property. What is that and why? But what is it? What's the answer first?
1,
Why?
because
Anything to the 0 power is 1. Why? Again, I said, don't just memorize it. You have to know why. It's the reason why that makes it understandable. Anything to the power 0 is always 1. We've talked about, with what we talked about this morning, you can prove this. No. Which property are we going to use? This is how you do a proof in math. If you can't go this way, you go this way. Because remember, that's what an equal sign means. So let's start. What do we know equals 1? Okay, 1 equals 1, but we haven't gotten anywhere. We're just repeating the same thing. If somebody asks you define horse, horse. Horse. No, that's what we just did. So we haven't done anything yet. So what else equals 1 always? What's that? You haven't done anything yet. You just use the same number. Then you'll say 1 times 1 times 1. 1 divided by 1. No, that's it. That's just nothing. You haven't given me any proof.
a number divided by itself.
Any number divided by itself. That's true, isn't it? Any number divided by itself. Now we know the rules. Since they have the same bases, what do we do with the exponents? We subtract them since it's division. N minus n is 0. That's the reason anything to the power 0 is equal to 1. Remember, when you teach, do not just put in, here's the rule, memorize it. Never do that. Always give the reason why. This, as an instructor, is first off, that's the question the students are always going to ask you. Why? If you can't answer that, then it's up to you to figure out why. If the students don't ask you that, you have to ask yourself, why is that? Why does that equal that? Here's an example. With what we've discussed so far, right as only one exponent. Do they have the same base?
Find a common base between all of them.
How are you gonna do that?
By first analyzing its focus.
What is 8 made up of? Just 2? 2 times 4. Can I go any further? What is 4 made up of? So 8 is 2 to the third. What about 16? 16 is 4 times 4. 4 is 2 times 2, 2 times 2. So it's 2 to the fourth. Eight is 2 to the third. 16 is 2 to the fourth. You're right. We have to first break down these numbers down to the smallest. It's called primary factorization. The next thing I do, what can I do with this parenthesis? And then this one.
Why the exponent?
Yep, since it's power to a power, you multiply. 3 times 5 is 15. 4 times 3 is 12. Since all of the bases are 2, what do you do with the exponents? You add them. 6 plus 15 is 21. 21 plus 12 is 33. There's your answer. Any questions so far? All right. Multiplication algorithms. What is an algorithm?
So
A plan, a procedure. How would we do 4 times 12? How would you teach that to your students? Remember, always start off with what they know first. What do they know first? Manipulatives. How would you use our blocks to teach them this? Well, what is 12? What does 12 look like using our blocks?
1 long and 2 minutes.
1 long and then 2 units. Very good. How many of those do we need? Remember, multiplication is a series of additions, which is what this is telling us. It's 12 plus 12 plus 12 plus 12. Which is really 10 plus 2 plus 10 plus 2 plus 10 plus 2 plus 10 plus 2. That's what we have. We have 10 plus 2, 10 plus 2. These all equal 12. Add up all the 10s. Add up all the 2s. Then we get 48. We can add 2, 4, 6, 8, 1, 2, 3, 4, or we could have just done it this way. 4 times 2 is 8, 4 times 1 is 4. You have to be able to show it to the students multiple ways. Bless you. That's easy when you have a single digit. You take this number, whatever that is, and do it that many times. What if you have two two-digit numbers? You wouldn't want to use the blocks anymore. Well, yeah, because you have to have 14 sets of 20s and then 3s. So how do we change it? How do we do that? What is 23 made up of? 20 plus 3. And then this is 10 plus 4. 20 is made up of 2 times 10. 10 is made up of 1 times 10. So now what do we do with this? Have we seen this type of equation before? Where? The foiling technique. So here we have 2 times 10 times 1 times 10. That's this first set. Then we have 2 times 10 times 4. 1 times 10 times 3. And then 3 times 4. Ten times 10 is 100, or 10 squared, the other one. 2 times 1 is, so it's 2 times 100, which is 200. Then we have 2 times 4 is 8 times 10. Here's an important thing. Why don't I distribute to both of those, 2 and 10 by that 4?
This is where 48.
There's a difference between 4, 2 plus 10 or 4, 2 times 10. There's a difference. This one says I have to distribute. This one simply says I have 4 times 2 times 10. Since they're all multiplied. So I do 4 times 2 is 8 times 10. Same thing here. 3 times 1 is 3 times 10. Then 4 times 3 is 12. So this is 80. This is 30. Then what do we do with these 4 numbers? Then we multiply them. 8, 9, 10, 11, 12. Carry the 1. 322. Okay, we have to break it down. And then eventually you can show them the shortcut method we all know. But remember, you have to connect it to what they know already. So this is the ones. 4 times 3 is 12. Carry the 1. 4 times 2 is 8. Plus 1 is 9. This number is in the tens. So I have nothing in the ones. I'm in the tens now. 1 times 3 is 3. 1 times 2 is 2. Now we add them. And we can also do 3-digit numbers. And it's also easier for adults to do these things too. How would you introduce that to a student? Yeah. So this breaks down to 4 times 300 plus 60 plus 7. 3 times 100. 6 times 10. And 7. So you do it in 3 steps. 4 times 3 is 12 times 100 plus 4 times 6 times 10. What's 4 times 6? 24 times 10. And then 4 times 7, which is 28. The reason this is easier for a lot of people is there's no worry about carrying overs just yet or anything. If you're multiplying by 2 zeros, take your number and put 2 zeros behind it. This is a 10, so anything times 1 is itself with 1 0 behind it. Then we just line them up and add. You notice in the first column, you won't have any carryovers because since you're multiplying by tens, there's always a 0 at the end. It's going to be 8 4 plus 2 is 6. 2 plus 2 is 4. And 1. Add up all. Obviously, using manipulatives will be cumbersome. You need a lot of blocks. And breaking it up to these subdivided categories is very time consuming. There's another method. Remember when we did lattice addition? How that helped? We can use the same basic concept for multiplication. Since we have two-digit numbers. The 23 goes here. And the 14 goes here. Again, these are our lattices. So in this first one here, what is 3 times 1? 0, 3. 3 times 4. 2 times 1. 2 times 4. 0, 8. You notice you have to put the numbers in each column. And now you put down all your numbers. 2, 8 plus 1 plus 3 is 13, so carry the 1.
About 12.
8, 9, 10, 11, 12, 12, sorry. Carry the 1. 2 plus 1 is 3. And then zero. So 322. Yeah, thank you. We're running out of time. Let's look at estimations. So again, the lattice method, majority of the time people use it is stress-free because everything's lined up for you. Mental math. 8 times 26. So the problem is, what do we do with 26? There are 3 possible ways we can do it. I know you never thought about that. No, I'm gonna put it over there. So the first one, what is 26? That's 20 plus 6. So 8 times 20 is 160. 8 times 6 is 8 times 8, 64. And add those together, you get 208. That's one way. Again, now what's 26? Let's break it down to easier numbers. 20 is easiest, but can we do 25 plus 1? So 8 times 25 is, because 4 times 25 is 100. So 8 times 25 would be, then 8 times 1 is 8. Add those, you get 208. Or you can go bigger. 26 is the same thing as 30 minus 4. Because you're going to pick whatever number is easiest for you to do that calculation. So 8 times 30 is what? 240. 8 times 4 is 32. Now we subtract them. So carry the 1. 10 minus 2 is 8. 3 minus 3 is 0. And there we have it. So basically, the crux of all this stuff is you can do whatever makes it easier for you. You can break the number down anyhow you want to. And then from there, you can just combine each separate part. So break it down to a bunch of addition, because why addition is much easier than subtraction or division or multiplication. So break it down to those pieces. All right. Unfortunately, we didn't finish this. We'll pick this up when we get back from spring break. Remember, no school next week. So definitely, I want everybody to be finished